Welcome to Mastering Solutions. In this momentum problem, they ask us two parts. They say, what is the impulse of the raindrop as it hits the roof? And then the second part is they want to know the magnitude of the average force as it impacts the roof. So let's start off with the first part. So A, let's go ahead and list the variables that we have. So the mass of the raindrop is equal to 0.014 grams. But in order to do that, they have a few common tricks to try to trip you up. And one of the biggest ones is they don't put things in SI units, so you have to convert it. So we have grams for the mass here, and we need to put it into kilograms for the SI units. So we're going to move the decimal place over 3. So 1, 2, 3. Okay, so 1, 2, 3. So that's in SI units now for the mass of the raindrop. And now they say the speed, the initial velocity, is equal to 8.1 meters per second. So now let's talk about what impulse is. It's obviously the change in momentum. So change in momentum is equal to the final momentum minus the initial momentum. If we think about conceptually what's happening, the final velocity of the raindrop is 0. So this is going to be 0. Now be careful doing that because we have to make sure that our sign is correct. Because if you remember, momentum and impulse, there is a vector component to it. So the sign has to be correct, notating if it's which direction it's going into. And so if we break this up, we have mass times velocity. We'll just put final like that, minus mass initial velocity initial. Now we can simplify this out because the mass is staying the exact same. So if we simplify this equation, we have the mass is equal to the velocity final minus the velocity initial. So now when we plug in our variables from our list that we made, we have our mass, which is 0.000014. Obviously, we can write that a little bit easier in scientific notation, but I'm going to leave it just for that way right now. And then we have 0 meters per second minus the initial velocity. And this is where the book is being a little tricky because what they say is the initial velocity is a negative 8.1 meters per second. And so when we do that, now we're going to end up with a positive answer, meaning the impulse is positive, which is what we need. So now when we plug this into our calculator, we have 0.0004014 kilograms times 8.1 meters per second gives us 1, 2, 3, 4. So the impulse imparted is 1.1 times 10 to the negative 4 kilograms times meters per second. So this is the answer for part A. So now let's give us a little bit more room down here. And they tell us that the change in time for part B is 0.37 milliseconds. So when we move the decimal place over, we get 0.00037. Make sure I did that correctly. We have 1, 2, 3. So that is seconds. And we can write that in scientific notation with 3.7 times 10 to the negative 4 seconds. So now let's talk about the formula for impulse, because impulse, another way can be written, the average force times the change in time. And of course, we have the impulse from the last question right here. So we have J, and they just barely gave us the change in time. So we just need to solve for the average time. So let's multiply both sides by T. So F average is going to be impulse divided by the change in time. Okay, so force average is when we plug all this in. When they plug it into the calculator, they add more units than we put for our answer above. So we'll do what they did. So it's 1.13 times 10 to the negative 4 kilograms times meters per second. And then we'll divide that by the change in time, which we said was 3.7 times 10 to the negative 4 seconds. Now the units, it's a force, so it needs to be in newtons. And a newton, if you recall, is kilograms times meters per second squared. And we have kilograms times meters per second divided by another second. So kilograms per meters per second squared, or newtons. So we know the math is correct. And now let's plug that into our calculator here. So we have 1.13 times 10 to the negative 4 divided by 3.7 times 10 to the negative 4 gives us 0.31. Kilograms times meters per second squared, or newtons as the average force.